Hi again, everyone. Here is the last 2 pages of the review. Here we go. Judging from appearances, does each figure have rotational symmetry? Remember, that's 180 degrees or less to get back to the original figure. So like number 1, you would have to go 360 to make it look exactly like that, so that's a no. This one, if I rotate it 180, I would get back, and that is okay. So this is a yes. It has a 180 degree rotational symmetry. This shape, how much would you have to rotate it so that it looks just like this again? Looks like 90 degrees. Okay? All right, so the vertices of a triangle are given. Graph each triangle and its image after a rotation of 90 and 180 about the origin. Name the coordinates of the vertices of the image. Okay, so the first one is 1, 4, 1, 1, and 4, 2. Okay, so here's our first little triangle. Okay, it wants a rotation of 90 degrees. Now remember, you could use the formulas from our notes, or you could do the paper turn. I'm going to do the paper turn for the 90s. So A, 1 to the right, 4 up. 1 to the right, 4 up. That's going to be A prime. B, 1 to the right, 1 up. 1 to the right, 1 up. That's going to be B prime. C was 4 to the right, 2 up. 4 to the right, 2 up. Now let's see, does that look like the triangle turned 90 degrees counterclockwise? Remember, we're supposed to go counterclockwise unless they tell us different. So did that turn 90? Yeah. Okay, and it wants the points. So A prime is -4, 1. B prime is -1, 1. And C prime is -2, 4. Okay, now the 180, I use the formula for because it's just an easy one to remember. The 180 is -x, -y. So if I'm moving the original 180, I'm going to look at the original points and just make them the opposite of what they are. And I'm going to plot those. So A double prime is -1, -4. A double prime. You could do the paper turn thing with starting with the prime, go 90 from there. That's another option. Here's B double prime and C double prime. And that should look like it turned another 90 from the last guy. Does that, yeah, that A looks like it turned 90. Okay, good. All right, same thing for this one. S is 2, 3. Here's S. T is -2, 4. And U is -4, 2. Okay. So we got another triangle here. There we go. There we go. And there we go. And we want to rotate that 90 degrees. Okay. So S is right 2 up 3. Right 2 up 3. Here's where S prime's going to be. Oh, I hate when I write it like that. T, left 2 up 4. Left 2 up 4. That's T prime. And U, left 4 up 2. Left 4 up 2. Is this going to look like it turned 90 degrees? Yeah, took a turn 90 degrees. Okay, and the points are -3, 2, -4, -2. And for u prime, -2, -4. All right. And again, I'm going to use the same, thing for the 180. I'm going to take the original and make the coordinates the opposite. So this would be -2, -3. This -2 would now be +2. Same thing here. This -4 will now be +4. So everything kind of switches. And let's see, we got -2, -3. That's going to be S double prime. 2, -4 is T double prime. And 4, -2, U double prime. There we go. There we go. And there we go. Whew. Nice. Okay. Oh, and this is kind of from our notes. Look for a pattern in exercises 4 and 5 to complete the following. The 180 we've been using. The 90 you could probably figure out. You take the y, you make it the opposite, and you put the x where the y was. That's confusing to me, but if you can memorize that, go for it. All right, one more page. This is it for the review. Okay. Draw a triangle with the coordinates, boom. All right, 2, 1, 2, 3, 4, 5, 2, 6, 8, 5, 3, 4, 5, 6, 8, 1, 2, 3, 4, 5, and 4, 1, 1, 2, 3, 4, 1. Okay. So there's our original. I guess they're not giving us letters to label it this time. Feels odd, but we'll go with it. All right, there's our original triangle. It says multiply the second coordinates in problem 1 by -1 and draw the new triangle. Okay, so 2, -6, 8, -5, and 4, -1. So 2, -6, 8, -5, and 4, -1. What does this look like just happened? It's got to either be a translation, a reflection. Oh, this is what it says. Is this a reflection, a translation, or a dilation? It's not a dilation, didn't change size. It's not a translation because it moved, how it looks. Is it a reflection? It looks like a reflection right here. Yes. Okay. Multiply the first coordinates in problem 1 by -1. Okay, so we'll get -2, 6, -8, 5, -4, 1. Okay, -2, 6. Can you tell what's going to happen? -8, 5, and -4, 1. What happened this time? Do you see it? A reflection over the y, so yes, it's not a translation, it's not a dilation. Cool. All right. Number 4, subtract 3 from the second coordinates in problem 1 and draw the new triangle. All right, you should kind of know what's going to happen here. Subtract 3 from the second coordinate, so 6 minus 3, 3. 5 minus 3, 2. And 1 minus 3, -2. Okay, let's see what happens. 2, 3, 8, 2, and 4, -2. What happened this time from the original? I believe it just took the original and shifted it down 3, right? Which one is that? That should be a translation. So it's not a reflection, it's not a dilation. Okay. All right, last thing here. Draw a triangle formed by these points, multiply each coordinate by 2, and then draw the new triangle. All right, we haven't done this one. 0, 0, and 3, 0. All right, so we start with this little guy. Right there. Okay, and we're going to multiply the coordinates by 2. So it'll be 2, 8, still 0, 0, and 6, 0. All right, 2, 8, 1, 2, 3, 4, 5, 6, hello, 8, still 0, 0, and 6, 0. Yes. And I think you know what should happen. This is a dilation. The triangle is similar, not congruent, similar, and it obviously got bigger. So this is a dilation, not a reflection, not a translation. All right, guys, all set with the review, and we will see you next week. There will be a problem set. Hopefully this helps you get ready for that. All right, keep it up.